This is section 5-3, dividing polynomials. We're on page 233. So this is what I'm going to divide a polynomial, and in this case we have a trinomial, 3 terms, divided by a monomial, 1 term. So we have open fraction 4x cubed y squared plus 8xy squared minus 12x squared y cubed all over 4xy, close fraction. And this looks like a daunting task. So the first thing we need to do is separate each term out and divide each individual term by our denominator. So our first term is 4x cubed y squared on the numerator. So we take that and we put it over our denominator. So we now have open fraction 4x cubed y squared over 4xy, close fraction, plus, looking at our second term, we have 8xy squared over 4xy, close fraction, minus, open fraction, 12x squared y cubed over 4xy. So now we have 3 more manageable things to divide. We have a monomial divided by a monomial, and then we'll put it back together. So let's look at this. The first one, we have open fraction 4x cubed y squared over 4xy. So we'll look at the coefficients. We have 4 divided by 4, which is just 1, so those drop out. And then we have our x's. We have x cubed over x. And remember, when we're dividing like bases raised to exponent, we subtract our exponents. So we get x squared. And looking at our y terms, we have y squared over y, same thing. So then you end up with just y. So our first term is just x squared y. Now let's look at our second term. We have, it's added to our first term. So after our x squared y, we have a plus. Now, we have open fraction 8xy squared over 4xy. Let's first divide our coefficients. 8 divided by 4, 2. Now, looking at our x terms, we have x over x. Anything divided by itself is 1, so those drop out. Our y terms are y squared over y. Subtract that, and you end up with just y. Now, our last term we are subtracting. So far, for our simplification, we have x squared y plus 2y. Now we have minus. Now let's look at our coefficients. We have open fraction 12x squared y cubed over 4xy. 12 divided by 4 is 3. Now x squared over x, or x squared divided by x. Subtract our exponents, we end up with just x. And our y's, we have y cubed over y. So y to the third power minus 1 gives us y squared. So then our answer is x squared y plus 2y minus 3xy squared. And that is as far as we can go with that. That is our simplification. All right, now we're going to look at something called synthetic division. Again, we're going to be dividing a polynomial by a monomial. So synthetic division is a simpler process for dividing a polynomial by a binomial. So suppose we have a polynomial, in this case a trinomial. We have 5x cubed minus 13x squared plus 10x minus 8, and we want to divide that by x minus 2. So the first step we need to do is we need to write the terms of the dividend so that the degrees are in descending order, meaning they go from bigger to smaller. So we have 5x cubed minus 13x squared plus 10x minus 8. So we have all of the descending exponents represented. If we had one missing, we would represent that with a 0 as a placeholder. But in this instance, we do not. Okay, so then that's step 1. And we need to actually pull down our coefficients. So underneath of that we have, so our first term we have 5x cubed. So underneath that we write just the 5. Now we look at our second term. We have negative 13x squared. So we pull down that negative 13. And then we have plus 10x. So we pull down underneath that and we write it as 10. And then the last one, we just write down, pull down as a negative 8. We have no variable on that one. So now we have just the coefficients in order left to right: 5, negative 13, 10, and negative 8. Okay, so what do we do with this? That's when we come to, we're at step 2. So step 2, we need to write the constant r of the divisor. So let's first look at what our divisor is. That's what we're dividing it by. So we have x minus 2. Where the constant, in this case, our r, equals negative 2. But we want to write this in the form of x minus r. So we write that as x minus a negative r of negative 2, which becomes x plus 2. That's in the terms of x minus r. So we look at just our r term. So our r is actually a positive 2. So this is what we're going to use. We're going to put our 2 to the left of our coefficients. And in print, we write that as 2, little half box around it, and then all of our coefficients to the right of it. So we have 5, negative 13, 10, negative 8. And in Braille, you can write that as a vertical bar. Okay, so now we have that. And then we put an equal bar underneath all of those guys. So that is step 2. So first thing we need to do is bring down this first coefficient underneath that equal bar. Let's bring it straight down, which is a 5. So I brought that down directly under the 5, under the equals bar. Now let's move on to step 3. Okay, so we have that 5 below the equals bar. I'm going to move the whole entire equation down so we can keep using that. Okay, so basically I like to think of it like a bouncing ball. So we take the number to the left, that 2, our r value, and then we multiply it. And when we're multiplying it, I'm going to fix my equal bar. It's a little crooked. It's going to make it difficult. So I'm going to redraw that so it's a little bit easier to see and have enough space. Okay, so we have this 2, our r value, to the left of our coefficients. So then we take that 2 and we bounce down to the 5 below the equal bar and we multiply those guys. So 2 times 5 is 10. And then where do we put that 10? So we need to put that 10 under our second coefficient, so it bounces back above the equal bar and under the negative 13. So now we have negative 13, and below that we have a 10. When we add those together, so negative 13 plus 10, and below the equal bar we put a 3. Okay. So now let's move along to step 4. Okay, so step 4, we basically need to do the same thing as we did before. We multiply, so we have 2 as our r value. Our coefficients are 5, negative 13, 10, and negative 8. And we brought down our 5 below the 5. And we multiplied, and we got a 10 underneath the 13 and added. So underneath the equals bar, we have a negative 3. So then we take our 2, and we then multiply that 2 to our negative 3 that's under the equal bar. And we bounce that back up, so 2 times negative 3 is negative 6. So that goes under our next coefficient, which is a positive 10. So now we have 10 plus negative 6, and below the equal bar we put our 4. Okay, so that's step 4. So below the equal bar we now have a 5, a negative 3, and a 4. Okay, so step 5. So again, we have our R value on the left. Coefficients are 5, negative 13, 10, and negative 8. And below that, we have our equal bar. And under the 13, we have a 10. Under the 10, we have a negative 6. And under the equal bar, we have our 5 we brought down, our negative 3, and our 4. So again, we need to do this multiplication. We take our 2, we multiply it to that 4, which is 2 times 4 is 8, and then it goes above the equal bar as a positive 8. And then we add those. So negative 8 plus 8 is 0. Okay, so that's step 5. And what we do next is we put it all back together. We put in our x's. We have to figure out the number on this bottom row is our coefficient. So these are the coefficients of our quotient. So we need to start with the power of x that is 1 less than the degree of the dividend. The dividend, if you remember, going back up to the top, was 5x cubed, 13x squared, plus 10x minus 8. So we have a 5x to the third power. So now when we divide, our quotient is going to have to the second power. So we just basically put those guys on our coefficients. So we have 5, negative 3, 4, and 0. So we have 5x squared, and our next number is negative 3. So our coefficient is negative 3. 5x squared minus 3x plus 4. And then this last 0. So this 0 represents our remainder. So we have a remainder 0, which means that our original problem, x minus 2, went in evenly into our dividend. So our answer is 5x squared minus 3x plus 4.